Now let's go to predicate. What is the predicate? The predicate, let's go back to this sentence. This sentence says that 1 plus 2 plus 3 plus until n is n plus 1 divided by 2. If we consider this is a statement, that means a proposition, we are assuming we know what n we are talking about. Suppose n is 9,000, then we are talking about one sum to 9,000, okay? But generally, somebody can say, I don't know what the n I'm talking about. So n is not specified. So now n is a variable. So now this is called Pn. This is exactly fx. Okay, so it's like this. You have a function, fx, look what you learned in high school. You won't call a function an equation, right? Equation is like x plus 1 equals 0, okay? Solve x. You won't say solve fx, right? You say fx is something, and then you want to do something else. So this is the same. A proposition is like a statement, so it's like equation. And then a predicate is like fx. You just have unknown here. So for example, I said qx means x is even. And then rxy means x smaller than y. And s x, y, z is a squared plus y squared equals z squared, that x, y, z are integer. So what are these? Are they proposition? No, because I don't know what x you're talking about. If you say q2, that means you are saying 2 is even. Yes, this is a proposition. X smaller than y. Okay, why I'm saying this? First of all, this is predicate. It's not a proposition. So of course, we cannot say this is true or wrong because we don't know what x, what y. But here's the thing. Why we should not say it's true or false? First of all, we don't know x and y. Secondly, this sentence is also incomplete. Let's say x, y are complex number. Then I can tell you, complex number, you cannot have this. You cannot say 3i is smaller than 4, right? What the heck? 3i smaller than 4? No. So, very strict sense, this is what? Incomplete sentence. We just say it's not a proposition, and that's it. Okay? And here's the thing, the Fermat last theorem, xn plus yn plus zn, where x, y, zn are all integer, have no solution for x, y, z for n larger than 3. So this is what? A predicate, because x, y, z, n are all unknown. But if he mentioned, Fermat mentioned, let's say n is 5. Then, if I treat x, y, z as some known number, then this is a proposition. And then what? A predicate is a proposition valued function of logic variable. That means what? A proposition has a truth value 0 and 1. A predicate is like fx. So now, previously, we are talking about x. So proposition is just x. Now we suddenly go to fx. Can you say fx and x are the same thing? No, right? It's different thing. And then so this is the idea. This 1.1.43 is just name. We don't care. Okay? So this means what? Universe of disclosure is the set of all truth value of a logic variable. That means what? That means when you build a truth table, what's the universe of disclosure? What are the 0 and 1 allowed in the table are the universe of truth disclosure. In other words, basically it's saying that what is the area of thing we are talking about. So we have to give me an area. So now we talk about everything within this area. So this is the meaning. Okay? But this term has an important meaning. Domain. Domain means what are we talking about? The area we talk about. We will see this word a lot because we will talk about domain of a function. That means if we view domain as a map, function as a map, domain is the input and codomain is the output. So in this case, it's like what's the input of our logic argument? We have a bunch of statement or proposition, but we have to specify what are we talking about. Something like what I just said here. You cannot have 3i smaller than 4. No, okay? And here's the funny thing. What are the difference? For example, x is handsome is px. Px has the truth value depending on x. There's no y. This is error. Okay? Px is a predicate because who are you referring to? So it's not a proposition. But P Anderson is a proposition and the truth value of course is true. Okay? So therefore this is a proposition. So now you see what's the difference here? This statement means me. Only one object, me. This statement, all human on earth. It's different. You cannot compare me with all human on earth. That's different, right? So this is the difference between predicate and proposition. And this is another example. X plus 2 equals y is a predicate because depend on x, y. And this is not a proposition. But P11 is a proposition. So it's saying is 1 plus 2 equals 1? No, right? So the true value is false. And what's the hardest predicate in the world? This one is the hardest predicate. Pn, n is prime. So that means what? I suddenly give you a number. Tell me, is it prime or not prime? And there are people spending their whole life trying to understand this. And you can see there's no pattern here. It's false, true, true, false, true, false, true, false, 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 true. There's no pattern. So if you know everything about Pn, that means you know all the true value of this P for any n, you get Fields Medal, Nobel Prize, whatever prize. Yeah, this example shows that, like proposition. I just said proposition is something either true or false. I didn't say I know the true value now, I know the true value tomorrow. Remember the example, you will die tomorrow. Okay, now you are not die, so the true value is false. Same here. Pn, I just said, what is a predicate? It's just a thing with proposition as a variable inside, and then we need to find the true value. But I didn't say we know the true value. This is something that we don't know the true value. And again, like logic in the proposition sense, you can do the same thing of and or not in predicate. You can do the same thing. That's it. And then here's a new thing. You can convert a predicate to a proposition. So what we do these two symbols. These two symbols turn a predicate to a proposition. So the first thing is called for all. This means for all. It's turn A. It's A upside down. It means what? Let's say I have a predicate P, and now I let Q divided as for all x px. It means what? It means now I have to check all the x such that if px is true, then Q is true. That means what? That means if there exists one particular example that px is false, Q is not true. So here is an example. So now, example. Ax is x equal 1. Bx is x larger than 2. Cx is x smaller than 2. And my universe of disclosure, that means what the heck are we talking about? Is 1, 2, 3. That means x can take 1, 2, 3. Now I have a complicated statement. And now you should have feeling. Now math suddenly get complicated. It's because of this kind of thing. I have a statement for all x, Cx implies to Ax. Is this true? How do you know it? Just try all the x. So for example, C1, what does it mean? C1 means 1 smaller than 2. Yeah, 1 smaller than 2. So is x equal to 1? Yeah. So 1 imply 1. Yeah. So okay. Now this is for all x, right? C2 is 2 smaller than 2? False. Anything false, I don't clear. X far so call it back. True. C3, 3 smaller than 2? False. X far so call it back. I don't care. Anything false is true. So this whole sentence is true. Okay, what about this? For all x, Cx or Bx is false. 1, 2, 3. So C and B, C1 is 1 larger than 2. 1 larger than 2 is false. Okay. B is 2 smaller, 1 smaller than 2. So it's true. So 1, 0 or the or give us 1. Okay. And then for 2, Cx is 2 smaller than 2 is false. And then Bx is 2 larger than 2 is false. Okay, that's why it's false. Okay, that's why you get a false. Okay. Now you see, things can get complicated. Now if I mix up this kind of if then for all they exist. And this is the reason why math is hard. And then for the opposite of for all, that means there exists. There exists is writing like this. Well, for all is A upside down. Okay. Then what about there exists? Well, if we turn E upside down, it still looks the same. So that means we flip it left and right. That's it. If you flip A left and right, it's the same A, right? So this is the only reason why we have these two funny symbols. So we flip A upside down because it's a symmetric vertically. And we flip E horizontally because it's symmetric horizontal. So now we have this. Okay? So what is there exists? It means for some x, px. So that means you just need to show me at least one. Then done. Okay? So now let's look at example. Cx means x is a cat. Mx means x eat meat. All cat eat meat is the same as for all x, Cx implies Mx. Okay, so this is the predicate under a quantifier becoming a proposition. Let me repeat. This guy alone is a predicate. It's not a proposition because x is a variable. This guy alone is also a predicate. It's not a proposition because x is an unknown. Two predicate with a if symbol is still a predicate. It's like an or not, right? But after you add this guy, this whole thing now is a proposition. Then we can say true or false. Okay, is this true? I don't know. Maybe some cat don't eat meat. I don't know. So this one, again, this is a proposition that I don't know the true value, but I can tell this is either true or false. Here's another thing. There is a number less than 7. Then I just write there exists x smaller than 7. That's it. If f is continuous, then f is differentiable. I didn't say what f, right? So I would say CF, F continuous, DF, F differentiable. Why CD? Just because start with C, start with D. Or you can draw a chicken or draw a dog here, doesn't matter, okay? Then, here's a fact. You learn later. There is a continuous function, but not differentiable. So what I'm saying, there exists a function F, bracket. This is false. So I have a not here. You may wonder, what are these functions? Absolute value. Absolute value is not differentiable at 0. Or this function, which is continuous everywhere, but not differentiable everywhere. Wow, we learn it later, okay? And then this Archimedean property. Okay, we talk about it again. That is, for any rational number, we can write as A and B. Archimedean, many years ago, 1,000 years ago, said that they always have a, if you give me a number, I can always give a number larger than you. Basically, that's the meaning. So basically, let's say you give me 1,000. Okay, I give you 1,001. If you give me 200, or I give you 201, I just plus 1, done. Or plus 0.1, or plus 0.5. So this is basically what he means. The implication is that means there's no biggest number. This also means there's no infinity. Because if you give me a number so-called infinity, okay, then I give you infinity plus 1. And then you give me back infinity plus 1, then I give you back infinity plus 2. And then that's non-stop. So this is his proof that there's no infinity. And mathematically, yes, there's no infinity because infinity does not belong to real number. Okay, we didn't talk about set yet, but I just let you know now. Okay, in other words, there's no ceiling. No ceiling means you don't have a maximum element. You don't have something that you can reach the top. You can always keep going. Okay, and then now this is the funny part. We just discussed what is a predicate, and if we do this, we can turn it into a proposition. Now that means what? We can do the thing in the proposition by adding an or not here. So this is just adding a not. So not for all x, px is the same as there exists x not px. This is De Morgan's law. Okay. So for example, all primes are odd. The negation is there exists 2, which is prime but not odd. Another example. Some prime larger than 2 are even. The negation is all prime larger than 2 are odd. Okay. The even here is the p. The odd here is the not p. Okay. Or you can say are not even. Now here's a fun. This guy want to prove himself exists many years ago. He said, I think, therefore I am. Okay, let's find the negation of his statement. So for all x, that means for all human, if x think implies x exists. So recall that A implies B is the same as not A or B, right? Or I put a double negation outside, and then I apply De Morgan's law for one of them, then these two cancel out, and I have a not B here, so this is why I have this. Okay, so A implies B is the same as not bracket A and not B. Now I want to negate what this guy is saying. So it will become, well, this is for all, right? For all become there exists. Okay, something like this. So here is the proof. His statement is, for all human thing implies human exists. Now I want to find the negation of this. I just add a big bracket, just add a not here. And then now I'm using this. I just explained here and here. So now this part is this part, right? Then what I'm going to do next? Well, I'm going to do is, there's a not here, right? There's a not here, right? I can not this guy and not this guy. This is De Morgan's law. So now I have this part give me this thing. Okay. This not here give me this not. And I just showed you previously, not is nothing. That means it's identity. Identity means do nothing. So I can just write nothing. Then I have this thing. And then negation of for all is there exists. Okay, and then now I have this. Done. Now we translate back this to English. A means a human thing. Bx means human exists. Then not bx means human not exists. So the opposite of what he said is there is a person thing, but that person does not exist. So that means something not exists but thinking. Okay, we are talking about logic. We are not talking about common sense. So I'm not going to judge whether or not this makes sense or not. I'm just saying, if this sentence, the logic value is true, then this sentence, the logic value is false. But I don't know, because is this really the proof that human exists? I don't know. So that's philosophy, not logic. So I don't care. That's it. And then now do the converse, inverse, contrapositive in your spare time. Try to think of some funny sentence like this. Okay. Here are more. I will skip this. Look at this. Let's say LXY, this is binary operator. So now I connect two things. Means X love Y. And let the universe disclosure, that means what are we talking about is just all people. So for all X, LX, LS means for everybody love LS. And then this one is a very long one. So negation of for X, LX Bob. So this bracket part is the same as the LS part. I just replace LS by Bob, right? Now I have a negation and I get this. So that means what? This part is like not everybody love Bob. That means there exists somebody not like Bob. Okay? Important. I didn't say the opposite of love is hate, right? It can be indifferent, it can be ignorant, it can be something else, right? So I didn't say there exists somebody hate Bob. No, I just say not. You see, I just say not. Okay? Let's say this one. There exists Y, negation L Bob Y. That means what? There is somebody, which is the Y, that Bob does not love. Because the negation here. Okay, let's say I talk about the second last. There exists X, negation LXX. Again, I said you can put any XY. Who said you cannot put XX? So there's somebody don't like himself or herself. Okay, this guy is a sad person. Anyway. So what about this? There exists some X for all Y. LXY implies X equal Y. What the heck? So let's think about it. There exists X, that means there is some person, call them Mr. X. Okay, that this Mr. X what? Love Y. Because this means X love Y. So this is the one who loves somebody. This is the one being loved. Okay. So there exists a Mr. X that loves any Y. Okay. And then this implies X is Y. What does it mean? It means there is somebody, Mr. X, who loves no one beside himself or herself. So this is the ultimate selfish guy. Because for all the Y in the whole human population, whenever he loves, this is true, that means he only loves himself or herself. Okay? This is fun, so practice. Here's the thing, practice. Rows are red, so I can say X is rose and X is red, then I can have this. For all flower, if X is a rose, implies X is a red. Again, let me recap. We are doing logic, so there's no free will. Don't tell me, oh, the first 4 months of a rose is still growing, it's a white color, it's not red. No, we're talking about logic. So if what defined as a rose, logically is a rose, then it must be red. No freedom, okay? And then you can do the same thing for sunflower, red lily, whatever thing, and then you say, okay, sunflower is yellow, so it's not true, blah, 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 okay? So this is predicate. That's it. And the next part is optional. But I mention this because this is useful. What the heck is sequence? It's basically a bunch of Latin. Yes. So basically, it's how do you prove things? Very simple. Somebody, this guy, makes something that looks like this. Basically says that if premise 1 is true and if premise 2 is true, you get conclusion. And this is his system. I don't like his system. I like my system. My system is this. So these three things are the same thing. What he writes is that if P implies P3 is true, and now we see P1, then of course we will have P3. This is the first way to write it. This is his way. So, for example, Amy graduate. Amy get a job. Suppose I now to English. If Amy graduate, then she get a job. This is considered to be a true statement. Don't say unemployment or a car crash and then she has to go to hospital. No. We assume in a hypothetical world, if Amy graduate, no free will, she will get a job, even she want to be lazy. No free will, she get a job. Okay, now, Amy graduate. Because of this sentence, of course, she get a job. Again, we are talking about logic in the computer, not common sense. So this thing can be written like this. Amy graduate implies Amy get job. Now, Amy graduate. Therefore, Amy get job. This is sequence. But I don't like this. I will just write like this. P imply P3 and P1 imply P3. Done. It's a tautology. That means always correct. How do you prove this? Again, proof table.